to review for the NCBN 0324 and for the Math 1324. Okay, exam to review consists of Chapter 6, which is solving systems of equations. So I'll be covering systems of two linear equations and two variables, larger systems of linear equations, applications of systems of linear equations, basic matrix operations, matrix products and inverses, and applications of matrices. Okay. So to start off, number one says determine whether the given ordered list of numbers is a solution of the systems of equations. Okay, so here guys, all we're going to do is we're going to plug in -1 for x and 3 for y on both equations 1 and 2. Okay, so let's first start with equation number 1. I'm going to plug in -1 for x and 3 for y. Right, then we evaluate -2 plus 3 will give us 1. So 1 equals 1. So that means this point is a solution for equation number 1. But for it to be a solution to the system, it has to be true for both equations. So now we can proceed and go to equation number 2. And again, I'm going to plug in -1 for x and 3 for y. At the end, this gives me 9 equals to 9. So this is a solution to the systems of equations because it makes both equations true. Now let's repeat the process on number 2. Again, we're going to plug in, for number 2, we're going to plug in 2 for x and -0.5 for y on equations 1 and 2. So let's first start with equation number 1. We're going to plug in 2 for x and -0.5 for y. Okay, after we evaluate the left side, it's going to give us 1 minus 4, which will give us -3. So -3 does equal to -3. So then that means that we can proceed to equation number 2. Again, repeat the process. I'm going to plug in 2 for x and -0.5 for y. In this case, after we evaluate the left side, it's going to give us -0.5 equals to -5. And this is not true, right? Because -0.5 is not equal to -5. So therefore, this point is not a solution to the system because it does not make both equations true. So number 1 is a solution and number 2 is not a solution. Okay. Now solve the system by graphing. So in this case, we're going to graph equation number 1, right? So the slope is 3, so it's going to be 3 over 1. And the y-intercept, or the b, is -6. And the 0, -6 is my starting point. So I'll start at 0, -6 here at the bottom. Then I'm going to go up 3, 1, 2, 3, and 1 to the right. And we connect the 2 points. That's my line for equation number 1. Equation number 2 is not in the y equals to mx plus b form, right, which is a slope-intercept form. So I need to rewrite it in the proper form. So I'm going to add 5x to both sides. After I do that, it's going to give me -2y equals to 5x minus 10. Now I divide both sides by -2. That gives us y equals to -5 over 2x plus 5. Now it's in proper form, so now I know what my slope is -5 over 2, and my b is 5, and my y-intercept will be 0, 5, and this is my starting point, 0, 5. So I'm going to go to 0, 5 on the graph, which is up here. Then I'm going to go down 5, 1, 2, 3, 4, 5, and 2 to the right, 1, 2. There's my point. Now I connect the 2 points, and it gives us the point where they intersect, which will be 2, 0. The point where both lines intersect is my solution, which will be 2, 0. Okay, now I'm going to do the very same one, but I'm going to do it by substitution. Okay? By substitution, it means that you have to solve for either x or y on either equation 1 or 2. And then in this case, number 1 is already set up in that form, right? Because y equals to 3x minus 6, which means that I'm going to go to equation number 2, and I'm going to plug in 3x minus 6 where the y is. Right, so we plug it in there. Now we're going to distribute. So we're going to get -5x minus 6x plus 12 equals to -10. Now we combine like terms, which is a negative 5x minus 6x will give us negative 11x plus 12 equals negative 10. Now I'm going to subtract 12 from both sides. This is just simple algebra, right? So subtract 12 to both sides is going to give us negative 11x equals to negative 22. Now I divide both sides by negative 11, and it gives us x equals 2. Now, but remember, guys, the solution is an ordered pair. It's a point. It has an x value and a y value. So therefore, I got my x value. Now I need to find my y value. So now you go back to either equation 1 or 2, and you're going to plug in the value for x, which is 2, and solve for y. Right? In my opinion, it's easier to go to number 1 because the y is already isolated. So on number 1, I'm going to plug in the 2 for the x. And then I just simplify, so it's going to give us y equals to 6 minus 6, y equals to 0. So I found my solution, which is x equals 2 and y equals 0. That's my solution for this one here. Okay, now let's do another one. No, this one says solve the system by elimination, which means when you solve by elimination, both equations must be in the form of ax plus by equals c. Okay? You see, they both have to be in that form. Equation number 1 is not in that form, but equation number 2 is. So equation number 1, I need to rewrite it in proper form. Therefore, I'm gonna add 2y to both sides. So we have x plus 2y equals to 19. Now it's in proper form, right? So we rewrote equation number 1 in proper form, and we keep equation number 2. Now solving by the elimination method, you're gonna have to cancel either the x's or the y's. It doesn't matter. I mean, whatever you think is easier for you. But what I see here, guys, is that the x is already by itself, right, in equation number 1. So I'm going to multiply equation number 1 by negative 4. Why negative 4? Because negative 4 times x will give me a negative 4x. And then when I add them, both equations together, the x's will be eliminated. But in mathematics, you have to multiply negative 4 times both sides of the equal sign. So negative 4 times x will give me negative 4x. Negative 4 times positive 2y will give us a negative 8y. And negative 4 times 19 will give us a negative 76. And equation number 2, all we do is slide it over. Now we combine them, right? Or add them, or add the 2 equations. So we get, these will be eliminated, the x's. Negative 8y minus 3y will give us negative 11y. And on the right side, negative 76 minus 1 will give us negative 77. So now we're going to divide both sides by negative 11. After we do that, we get y equals to 7. So I got the y value. Now I need to find the x value. So for this one, you can either go to equation 1 or 2, right, to solve for x. Again, in my opinion, right, it's easier to go to number 1 because 1 is already by itself. I mean, the x is already isolated. So it would be easier to go to number 1. So I'm going to plug in the 7, right, where the y is, because the value for y is equal to 7. So I'm going to plug it in there. Then we simplify. So x equals to negative 14 plus 19. So x equals to 5. So I got my x and I got my y, which is 5 for x and 7 for y. So this is my solution, 5, 7. Okay, now, again, solve the system by elimination. Because in this case, you see both of them already in proper form, in the ax plus by equals c. So now here, we're going to decide why we want to eliminate. Okay, in my opinion, they're both the same. So in my opinion, let's eliminate the x's. So to eliminate the x's, you're going to multiply equation 1 by negative 2. And again, why negative 2? It's because negative 2 times 3 will give us negative 6. And then when you add it to the 6, right, for the 6x, they will be eliminated. But I need to multiply negative 2 times every term. So negative 2 times 3x, negative 2 times negative 2y, and negative 2 times 4. That's going to give us negative 6x plus 4y equals to negative 8. Equation number 2, all we do is bring it over, and then we add them. In this case, guys, we're going to get 0 equals to 0. What does that mean? Right? We don't have no x's or y's. It just means that there's going to be infinite solutions. So the answer will be infinite solutions. Okay, now let's do a similar one now. We have 2x plus 5y equals to 8, and 6x plus 5y equals to 18. And again, they want us to use the elimination method. So again, I'm going to get rid of the x's. So I need to multiply equation 1 by -3. Right? But -3 times 2x will give us -6x. -3 times 5y will give us -15y. And -3 times +8 will give us a -24. Right? Then when we add them, it's going to give us 0 equals to -6. And again, what happened with the variables, with the x's and the y's? You see they were eliminated. But in this case, if you have 0 equals to -6, it's not true. That means there's no solution, which means the lines will never intersect. It means the lines are parallel. So for this answer, is no solution. Okay, now this is how you apply these type of problems into an application word problem. Okay, so systems of equations. So here it states a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So here, guys, we're going to find two equations. We're going to do seats with seats and money with money. Okay, what does that mean, seats with seats? Here's what it means. Okay, I'm going to let x, right, because adults are first, I'm going to let x equal to adults. I'm going to let y equal to children. Okay, and the total number of seats is 200. So with this information, we can get equation number 1, which will be x plus y equals to 200. Now let's do money with money, right? How much are the adult tickets? They're $8. But we let x, the variable, represent adults. So for this one, it's going to give us 8x. And now how much are the children's tickets? They're $5, right? Since y represents children's seats, then this is going to give us 5y. And what was the total income? It was $1,435. So for this one, guys, we got equation number 2. It's going to be 8x plus 5y equals to $1,435. So I found both equations. Right? Now, all you do is solving a simple linear systems of equations, guys, right? So here, I'm going to call it equations 1 and 2. So now we can solve it by either substitution or by the elimination method. In my opinion, since they're both in the same form, which is the ax plus by equals c form, it's easier to do it by elimination method. So here, guys, I'm gonna eliminate the x's, which means I need to multiply the whole equation 1 by -8. And again, why did I use -8? It's because -8 times x will give me -8x. And then when I add it to equation 2, the x's will be eliminated. But I need to multiply -8 times every term on equation number 1. The result, after we do this, it should give us -8x minus 8y equals to -1,600. Equation number 2, all we do is slide it over, right? Then we add them. So we get -3y equals to -165. We divide both sides by -3. And we get y equals to 55. So I got my y value now. But now I need to find my x value. So I'm going to go back to equations 1 or 2, right? It's easier to go to equation number 1 because it's easier to work with. We know that the value for y is 55. So I'm going to plug in 55 for the y's, and then subtract 55 from both sides, and we got our x value. So x is 145 and y is 55. But that's not what they want. What they want is how many adults and how many children were in the audience. Since adults is represented by X and children is represented by Y, so we're going to have 145 adults and 55 children were at the theater. Okay, this is how you work these type of problems here. Now this is a larger systems of equations. Okay. You guys remember the plan that I think I did this one about 2 weeks ago? The plan for these type of equations, we're going to get equation 1 and equation 2 and get rid of the x's. And similarly, we're going to get equations 1 and 3 and also get rid of the x's. So let me do that. So we're going to multiply equation 1 by -2. After I multiply equation 1 by -2, it's going to give us -2x plus 4y minus 4z equals to 0. Then we're going to bring equation 2 over. We're going to add them. So the x's are eliminated. So we get 4y minus 3z equals to 3. Now we're going to repeat the process, but we're going to use equations 1 and 3. So I'm going to multiply -3 times equation 1. Right, so it gives us -3x plus 9y minus 6z equals 0. And we just bring equation number 3 over. And now we're going to add them. This gives us 10y minus 7z equals to 7. So this is my new equation number 3. Okay, now I'm gonna get the new equation 2 and the new equation 3. We're going to get rid of the y's. Okay, so this equation 2, I'm going to multiply by -10, and equation 3, I'm going to multiply by 4. Right, because -10 times 4 will give us a -40, and 4 times 10 will give us a +40, and when we add them, they'll be eliminated. But you need to multiply -10 and 4 times both sides of the equal sign. So if we do that, this is my result. So if you notice, the y's are eliminated. So we got 2z equals to -2. We divide both sides by 2, and z is equal to -1. Now, once you do that, you can actually get 3 new equations, right? This is equation 1. Equation 2 was a new equation 2. And we got for equation 3, it became z equals to -1. Now, we're going to back substitute. So I got the value for z right now. I need to find the value for y. So I'm going to go to equation number 2. I'm going to plug in -1 for z and solve for y. Right? We subtract 3 to both sides. So 4y equals to 0, divide by 4. So y equals to 0. So now I got my z, which is -1. I got my y, which is 0. Now I need to solve for x. So I'm going to go to equation number 1, and we're going to plug in 0 for y and -1 for z, right? And then we're able to solve for x. So we got x minus 2 equals 0. We add 2 to both sides, so x equals 2. So my solution will be 2, 0, -1. That's where all 3 equations intersect. Okay. Okay, now this is a Gauss-Jordan elimination method. It says convert the linear system equation into augmented from the solve and then solve by using the Gauss-Jordan method. So systems of equations, right? So this is what we want to do, and we're going to convert it to RREF, which means reduce row echelon form. There's my system, right? To augmented matrix, we're gonna, this is my row 1, which will be 1, -3, 2, and 0. Then my row 2 will be 2, -2, 1, and 3. And finally, my last row, which is row 3, will be 3, 1, -1, and 7. Okay. Then I want to put it in this form, which means my x equals 2, my y equals 0, and my z equals to -1. Okay, but how are we going to do it? Okay, we have to do it by using the Gauss-Jordan method. Okay, this I call it the three-step plan. Okay, so my first step, right? So this is going to be my answer. So my first step right? I'm gonna make the 2 and the 3 zeros, right? Because you see they're color coded. This is my first step in blue. My second step will be in green, and my third step will be in red. So this is row 1, row 2, and row 3. So for step 1, I'm gonna make the 2 a 0 and also the 3 a 0. See, that's why I turn it to blue. That means row 2 is gonna change, and also row 3 is gonna change. We have to use row 1, right? So I'm gonna multiply -2 times row 1 and add it to row 2. And then for row 3, I'm going to multiply -3, row 1, and add it to row 3. And here's my work. All right, there's my -2 row 1 will give us -2, 6, -4, and 0, plus row 2. We just bring it over. It's going to give us 0, 4, -3, and 3. That's my new row 2. Now let's do the second part in step 1. So -3 row 1 is -3 times every element in row 1, which will give us -3, 9, -6, and 0. Then when I add it to row 3, it's going to give us a 0, 10, -7, and 7. That's my new row 3. Now on the next slide, I'm going to continue with step number 2. Right? So this is what we have after we did step number 1. So for step number 2, right, which is in green, which will be the -3 must be a 0 and also a 10. So step 2, we're going to keep row 2. And the -3 must be a 0, so that row is going to change. And the 10 has to be a 0, so row 3 is going to change. So we're going to use row 2, right, to eliminate the -3 in row 1. So I'm going to multiply 3 times row 2 and add it to 4, row 1. And with the second part, I'm going to multiply -10 times row 2 and add it to 4, row 3. And here's my work. Right, 3 row 2 will give us 0, 12, -99. Plus 4 row 1, multiply 4 times every element in row 1 is going to give us 4, -12, 8, and 9. After we add them, it's going to give us 4, 0, -1, 9. So that's my new row 1. Then come my second part for step 2. It's -10 row 2 plus 4 row 3. So I'm going to multiply -10 times every element in row 2. It's going to give us 0, -40, 30, and -30. Then you're going to add it to row 3. It's going to give us 0, 40, -28, and 28. So after we do the operation here, we get 0, 0, 2, -2. So here, guys, you're going to simplify. Remember last time that we did this? We simplify with go along and we can. So we divide everything by 2, so it's going to give us 0, 0, 1, -1. This is my new row 3. Now for the last step, I'm going to go to our next slide, and it's going to be color-coded in red. So step 3, we're going to keep row 3. The -1 on row 1 must be a 0. So that was going to change. And the -3 in row 2 must be a 0. So that was going to change. Okay, now, we're going to use row 3 now, right? So just by adding row 1 and row 3, right, that's going to give us a 0 where the -1 is. And here, right, we're going to multiply 3 row 3 and add it to row 2. And here's my work. Divide everything by 4, right, because this can be simplified. This is going to give us 1, 0, 0, 2. That's my new row 1. And then for the second part in step 2 and step 3, we're going to multiply 3 times row 3, which will give us 0, 0, 3, -3. Then I'm going to add it to row 2. This gives us 0, 4, 0, 0. This can be simplified. We divide everything by 4, so it's going to give us 0, 1, 0, 0. That's my new row 2. You see, guys, I've done it by using the Gauss-Jordan method. Here's my solution, which will be x equals to 2, y equals to 0, and z equals to -1. Okay, now let's do another one, right? But this one, we're going to do everything in one slide. Remember, step 1, we're going to keep row 1. So the 2 in row 2 and the -1 in row 3, those two must be zeros. So I'm going to change row 2 and I'm going to change row 3. So here, I'm going to multiply -2 times row 1 and add it to row 2. And for the second part, I'm going to add row 1 and row 3. And here's my work. -2 row 1 will give us -2, -4, 2, and -12. Plus row 2 is going to give us 0, -5, 5, -10. Okay, so this one, we divide everything by -5. So it's going to give us 0, 1, 0, 1, -1, 2. That's my new row 2. I'm going to do a second part, row 1 plus row 3. We're going to add them. It's going to give us 0, 1, 0, 1. That's my new row 3. Now for step 2, right, the 2 in row 1 must be a 0, so that's going to change, and also the 1 in row 3 must be a 0. So step 2, we're going to keep row 2. We're going to change row 1. We're going to change row 3. So we're going to be using row 2. So -2 times row 2 plus row 1 will cancel the 2 in row 1. And -1 times row 2 added to row 3 will cancel the 1 on the third row, second column. Here's my work. So -2 times 0, right? -2 times 1, and -2 times -1, and -2 times 2 will give us 0, -2, 2, and -4. When we add it to row 1, it's going to give us 1, 0, 1, 2. That's my new row 1. -1 times row 2 will give us 0, -1, 1, and -2. I mean, -1 row 2 plus row 3, we just bring the row 3 over. This gives us 0, 0, 1, -1. That's my new row 3. Now for the final step, step 3, we're going to keep row 3. So the 1 on the top, on the first row, right, on the third column, that's going to be a 0. So that means that row 1 is going to change. And the -1 in row 2 has to be a 0. So that means that the row 2 is going to change. Okay, so to eliminate the 1 in row 1, I need to multiply -1 times row 3 and add it to row 1. And to eliminate the -1, right, on the second row, third column, we just add these two. We add row 3 plus row 2. And here's my work. Plus row 1. It's going to give us 1, 0, 0, 3. That's my new row 1. Then row 3 plus row 2 gives us 0, 1, 0, 1. So that's my new row 2. And I'm done. The solution will be x equals 3, y equals 1, and z equals -1. There's my solution. Okay, now how are these matrices? I mean, by using the Gauss-Jordan method, how do we solve word problems? Here's an example here. So it says here, tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 470 people at the concert, and the total ticket received were $1,150. And 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Okay, we need to find 3 equations. So again, we do people with people and money with money to find the first two. So we're going to let x equals to adults, y equals to teenagers, and z equals to preteens. And there were how many people? There were 570 people, so it's going to be x plus y plus z equals to 570. Now equation number 2, right? If adult tickets cost $5 and x represents adults, this will give us 5x. If teenagers, right, tickets are $3 and y represents teenagers, it is going to give us 3y. And the preteen tickets are $2 and z represents preteens, so it's going to give us 2z. And the total income is $19.50, right? So we have our equation. So it'll be 5x plus 3y plus 2z equals to $19.50. So I found equations 1 and 2. We're missing number 3. Okay, now how do we find number 3? Number 3, we find it from the second to the last sentence, which says 3/4 as many teenagers as preteens attended. So this is what you get, right? Teenagers is y and preteens is z. So this is the answer here, guys. But how do we get that? If it is difficult, write it how it sounds and then switch it. How it sounds is like 3/4 as many teenagers, right? So in teenagers is going to be what, x. So it sounds like, no, teenagers is going to be what? Teenagers, yeah, it's going to be y because the adults are the x. So teenagers is like y and preteens is like z, preteens. So something how it sounds. Doesn't it sound like 3/4 teenagers or 3/4 y equals to z? And then you flip it or switch it. You switch the 3/4 to the z. Okay? And I've been doing it like this on my classes, and the student says that it kind of makes sense. Okay, that you write it how it sounds and then you switch it. So then, right, I need to have it in everything with integers. So I'm going to multiply 4 times both sides. Then I'm going to subtract 3z from both sides. So this is what it gives us. 4y minus 3z equals to 0. So I found my third equation. Okay, now, right, we're going to solve it. You can do it by the Gauss-Jordan method, but it's easier to do it how we did it with solving the systems of equations without using the Gauss-Jordan method. Again, we're going to use equations 1 and 2, get rid of the x's. So I'm going to multiply equation 1 by -5. If we do that, it's going to give us -5x minus 5y minus 5z equals to -$2,850. in 50. Right? After we add them, we get -2y minus 3z equals to -900. That's my new equation 2. If we notice, we don't need to, equation 3 is already said with no x. So this is my new equation. The equation 3 is like my new equation 3, right? Because the equation 3 doesn't have an x. Now here, guys, I'm going to eliminate the y's, which means I'm going to multiply equation 2 by 2. Again, why 2? Because 2 times -2 will give us -4. And then when I add it to equation number 3, the y's will be eliminated. Once we have -9z equals to -1800, we divide both sides by -9, and z equals to 200. Now I can go back and substitute. Let me go to equation number 2. I'm going to plug in 200 for z and solve for y. We add 600 to both sides. Divide both sides by -2. So y equals to 150. So I got the value for z and I got the value for y. Now I need to find the value for x. So we go to equation number 1. We know what the y and the z values are. All we do is plug them in. Y is 150 and z is 200. So it will be x plus 350 equals to 550. We subtract 350 from both sides. So it's going to give us yx equals to 220. So here's my solution. It's going to be 220 adults, 150 teenagers and 200 preteens were in the concert. Okay, now comes addition of matrices. Okay, this matrix is a 2 by 3 because you have 2 rows and 3 columns, and so is B the same. These are 2 by 2 and these are 2 by 2. So it says to add A plus B. So A plus B, right, we can add them because they're the same size. We're just going to add 5 plus 2, negative 1 plus 0, 6 plus 1, 3 plus negative 3, 4 plus 1, negative 2 plus 4. And this is going to give us what? 7, negative 1, 7, 0, 5, and 2. That's my A plus B. Can we add C plus D? Then C, 2 by 2, 2 by 2. Yes, we can add them because they're the same size. This is going to be 3 plus 2, 1 plus negative 1, negative 5 plus 8, and 0 plus negative 6. And here's my result. Going to give us 5, 0, 3, negative 6. That's matrix C plus matrix D. Can we add C plus A? C is a 2 by 2. A is a 2 by 3, so these are not the same size, so you can add, it's not possible, not the same size. Okay, similar guys with subtraction. 2 by 3, 2 by 3, and matrix C is a 2 by 2, and matrix D is a 2 by 2. So A minus B will be 1 minus 8, negative 3 minus 0, 2 minus 1, 2 minus negative 1, 2 minus 3, negative 1 minus 4. Right? So this is going to give us negative 7, negative 3, a 1, a 3, a negative 1, and negative 5. That's my solution. Okay, now let's subtract C minus D. It's going to be 5 minus 2, 1 minus negative 1, negative 4 minus 9, and 3 minus negative 7. And here's my result. It's going to give us 3, 2, negative 13, and positive 10. That's your solution. Can we subtract A minus C? A is a 2 by 3, C is a 2 by 2, so no, it cannot be done because they're not the same size. Okay, and that's how you add and subtract. Now let's do number 15. They give us matrix A is negative 2, 0, 5, 3. Matrix B is 0, 2, 4, negative 6. For A part, they want us to find negative 4A. For B part, 5B. And for C part, we're going to combine both of them, part A and part B. Okay, so let's start with part A. The negative 4, guys, is a cascader, which means that you're going to multiply negative 4 times every term in matrix A. Right, so negative 4 times every term. It's going to give us 8, 0, negative 20, negative 12. Now let's do B, which is 5 times matrix B. So I'm going to multiply the 5 times every element in matrix B, which would be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. Here's my result. 5 times 0 will be 0. 5 times 2 is 10. 5 times 4 is 20. And 5 times negative 6 is negative 30. So that's my solution for that one. Now for C part, I'm going to add negative 4A plus 5B. My negative 4A, right, is the one that we just got in part A. Plus 5B, the 5B is what we got in part B. Now to add them, right, we're going to add 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. Here's my result. It's going to give us 8, 10, 0, and negative 42. That's my solution for part C. Okay, now multiply matrix. So to multiply matrix, right, for example, it wants to multiply B times A. So B is a 2 by 2 and A is a 2 by 3. When you multiply a matrix, the inner numbers, right, after you put the size of the matrix on both matrices, you compare the inner numbers. If they're the same, it can be done. Yes, it's a match, it can be done. And the solution will be the outer ones, will be a 2 by 3. That's my solution. So this, I'm going to do it in a few steps. So step 1, right? Here also, guys, I'm going to use color code because the rule is that I'm going to multiply row 1 times every column. So it'll be 1 times 2 plus 0 times 4 is going to give us 2 plus 0. The answer is 2, which means 2 will be on the first slide right there. Boom. Now comes step 2. Step 2, I'm going to multiply the same row, but now we're going to multiply it times the second column, column number 2. It's going to give us 1 times 0 plus 0 times negative 2. It's going to give us 0 plus 0. The answer is 0. So the 0 will be on the first row, second column. There's my 0. So step 3, I need to do one more step for the first. For the first row, right? Because now I need to multiply the first row times the last column. So it'll be 1 times 5, 0 times negative 3. You're going to give us 5 plus 0, so the answer is 5. So the 5 goes right there on the first row, third column. Because if you notice, right, we're done with all the columns. So now we're going to do the second row times every column again from the beginning. So it'll be the second row times column number 1. It's going to be 4 times 2 plus negative 2 times 4. This will give us 8 minus 8 will give us 0. So the 0 goes right there on the second row, first column. Step 5. I'm going to multiply the second row times the second column. So 4 times 0 plus negative 2 times negative 2 is going to give us 0 plus 4. The answer is 4. And finally, we're going to multiply the second row times the last column. It's going to give us 4 times 5 plus negative 2 times negative 3. It's going to give us 20 plus 6. The answer is 26. So we're done. We're done with the matrix, and this is my solution when we multiply both B times A. That's your answer. Okay. Okay, now find the inverse of the matrix. Okay, for the inverse, there's 2 ways to get the answer. Right? This is called matrix A, and this is called the identity of matrix A. So you're going to use the Gauss-Jordan method from 6.2, and this will be your solution on the left side, on the right side. What you do here, guys, you try to put the right side, which is the identity, on the left side, and then whatever matrix is left on the right side, that'll be your answer. So in this case, this is my solution. Right? And here's how we do the work. The answer will be negative 3, 1, 2, and negative 1/2. In this case, I'm going to multiply right, row 1 and row 2. So I'm going to multiply negative 4 times row 1 and add it to row 2. And choose my work. Right, negative 4 times row 1 will give us negative 4, negative 8, negative 4, and 0. We're going to add it to row 2. So it's going to give us 0, negative 2, negative 4, and 1. So that's my new row 2. Now for the second step, I'm going to keep row 2. I'm going to multiply these two because if we just add them, they'll cancel. They'll give me a 0 where the 2 is. And here's my work. It's going to give us 1, 0, negative 3, and 1. So you notice we're almost done, right? But this has to be a 1. And we don't have a 1 there. So we're going to multiply row 2 by negative 1/2. If we do that, it's going to give us negative 1/2 times 0 will give us 0. Negative 1/2 times negative 2 will give us a 1. Negative 1/2 times negative 4 will give us a 2. And negative 1/2 times 1 will give us a negative 1/2. So this is my inverse. Okay. Now I'm going to show you another way to get the answer, which I think is easier. Okay, and here's a formula to find the answer of a 2 by 2 matrix on the inverse. Okay, here's the concept here. For the inverse, you're going to multiply 1 over A times D minus B times C. This is called a determinant. Okay, and then the A and the D switch places, right? And the B and the C, you switch the signs. I can repeat, the A and the D switch places, and for the B and the C, you switch the signs. So again, let's find the inverse. Okay, we have the very same one as before, right? So this will be 1 times 6 minus 2 times 4. The 1 and the 6, we switch them, and the 2 and the negative, and the 2 and the 4, right, we switch the signs. Then this will give us on the bottom 6 minus 8 will give us negative 1/2. So I need to multiply negative 1/2 times the matrix 6, negative 2, negative 4, and 1. It's going to give us negative 3, right? Positive 1, positive 2, and this will give us negative 1/2. So this is my inverse. Let me go back real quick. Right, this is your inverse, right? Okay, now I also show my students how to plug it into the TI-84 calculator. This will help you. You follow these steps, it's going to help you how to plug it in. But I always tell my students that this is only to check their work, but they have to show me all the work on the exam. Okay. To put into a matrix into the calculator, you're going to go to second matrix because the second means that the matrix is in blue. You're going to go to second matrix, and the matrix, the key is the inverse key. You're going to go second inverse key, and then you're going to go to edit. When you're going to edit, you're going to enter, and then you're going to enter the size of the matrix and enter all the entries. After each entry, you're going to put enter. Okay? Then you're going to go to second quit. And the quit, the key is going to be I believe the mode key. That's a quit, right? But it's in blue. Second quit, and the screen should be blank. Okay, that means that the matrix is inside the calculator. It's like a filing cabinet. It will always be there unless you replace it with another matrix, or you can reset the what's it called? Reset the memory. Okay, that's how you can get rid of it. But if not, it will always be there. Now, if you're solving, you're going to go again to second matrix, right? And then you're going to go down to math. Then you're going to go down to REF. REF means that it's called reduced row echelon form, which means you're going to get 1, 0, 0 in a number, 0, 1, 0 in a number, and 0, 0, 1 in a number. That's what that means. Okay, now you're going to go get the matrix, second matrix. Go get the matrix that you're trying to solve, and just enter. Right? Say it was matrix A, you enter, close parentheses, and you got your answer. Right? Now, right, and then you enter, right, to get the answer. If it was a 2 by 3 matrix, then the answer should look like this. Okay? Right, which is x equals to A and y equals to B. Now, if you're adding or subtracting matrices, not solving, just adding and subtracting, you want to store the matrix in the calculator, guys, and stop. And then you go get the other one and the other one and the other one, and then you do the operation. Okay, but this should be a guide on how to enter these matrices in the calculator, or you can also Google it and go to YouTube. Okay? Okay, now, let's go down it. So now, this is an applications problem. It says solve the matrix equation using AX equals to B. Solution. Right? We want to solve for X. So we're going to take the inverse of both sides, and the inverse on the left side cancels with the A. The inverse of A cancels, so we have X equals to the inverse of A times B. You need to find the inverse of a matrix and multiply it by matrix B. Okay, for example, using the inverse. A is going to be, right, it's going to be A, B, C, and D. Then the inverse, right? We did the formula earlier. Is going to be 1 over A times D minus B times C. Then the A and the D, right? You switch them. You switch the places, and for the B and the C, you switch the signs. Okay. For example, the inverse of matrix A is going to give us 5 thirds, negative 2 thirds, negative 1 third, and 1 third. Okay, if you do it this way. So now, right? So this is the inverse, right, of matrix A. So then, right? So then to find X, we're going to multiply the inverse times matrix B, which means I'm going to multiply 5 thirds times negative 3, right? This can be done, right? Because the two in the middle are the same, and the answer will be a 2 by 1. Okay, now I'm going to multiply 5 thirds times negative 3. It's going to give us negative 15 over 3. Then I'm going to multiply negative 2 thirds times 5. It's going to give us negative 10 over 3. And we add them, it's going to give us negative 25 over 3. That's the X part. Now to find the Y part, we're going to multiply negative 1 third times negative 3 will give us 3 over 3, right? Plus we're going to multiply 1 third times 5 will give us 5 over 3. After we add them, it's going to give us 8 over 3. So this is my solution, guys. Negative 25 over 3 and 8 over 3 is my answer. Okay, now how do we use what we just did, guys, to something like number 19? It says here, write a system of equations and use the inverse of the coefficient matrix to solve the system. Okay, here's how we do it. Solution. Let X be the number of days, because it says here, budget truck rental charges $19.99 per day plus 59 cents per mile to rent a 12-foot moving truck in Austin, Texas in 2016. The total bill for your move was $86. The rates of the local moving company were $10 per day and 95 cents per mile. And the bill for the same trip, which means same number of miles and same number of days, would be $94.10. How many miles and how many days was in the trip? So we let X equals to a number of days and Y equals to a number of miles driven. For equation 1, right? We have 19.99, we have 59 cents, and it's equal to $86, right? So it's going to be 19.99x plus 0.59y equals to 86. Now for equation 2, it's going to be, right, there's a $10, 95 cents, and 94.10. It's going to be 10x plus 0.95y equals to 94.10. Now we have AX, right? This is like AX equals to B. My A will be only the coefficients 19.99, 0.59, 10, and 0.95. Right? My X is going to be my X and Y. And the B is going to be the 86 and the 94.10. That's my B. Now you have to get the inverse and multiply by B. Right? You can use a calculator to find the inverse, round to 3 decimal places. So for the inverse for matrix A, all you do is can plug it into the calculator under matrix A and then hit the inverse key, and you got your answer. Right? This is the inverse of matrix A. Matrix B is 86 and 94.10. Now here, right, this will be the answer, guys. But how? I multiply 0.073 times 86, and then plus negative 0.045 times 94.10, and we add them, it's going to give us 2. And the same manner, guys, but all this can be done also in the calculator. Okay? So it's going to be 2 days and 78 miles. And again, guys, here, guys, you can plug this into the calculator, guys, to get the answer. Or you can do it another way. You can plug this in there, right, how it is, and go to REF, go down to REF like I did in the showing you how to get the answer with the calculator, guys, and solve it that way. Or solve it by the Gauss-Jordan method, or you can solve it by the elimination method, or you can solve it by the substitution method. There's different ways to get the answer, guys. And I believe I'll show you an example of almost each one, but they weren't like word problems, they were just regular equations. But that's how you apply these type of systems of equations to applications problems, guys. And that's it for today's PowerPoint. Hopefully this was helpful. Let me go back to the host so they can close out.
Thank you, Mr. Sassi, for your presentation. Again, we do want to remind everybody about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. So if you guys can please take a few minutes to fill out that survey. And before you all leave, I want to share the TVE sessions that we will have next. So at 1 p.m. today, we will have a presentation from the EPCC student clubs, and we will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover basic matrix operations and using matrix operations, and Math 1324 will cover sets. Our 1 p.m. session next week will be a presentation on emergency management. Thank you all for coming in today. We hope you all have a lovely 3-day weekend. If you have any questions, feel free to use the chat box or your mic, and we hope to see everyone again for Happy Math Hour.